Let us solve a problem on monopolist profit maximization. The question is, given the demand and cost curve of a monopolist is Q is equal to 50 minus 0.5 P, Q is the output, P is the price, and this is our demand curve. Cost function is being given as 50 plus 40 Q. We have to determine the profit maximizing level of output and price. Also, we have to find the total revenue and total cost, and then we need to find out the total profit. Okay. Now what we are being given this demand function for the monopolist. Okay, Q is equal to 50 minus 0.5 P. First thing is we find out the inverse demand function. That is, we solve this demand function for price. Okay, if we are being given Q is equal to 50 minus, in place of 0.5 I can write 1 upon 2 P. Transposing this here, it will become 1 upon 2 P is equal to 50. Transposing this to it will get subtracted. Okay, so P will be equal to, multiplying both sides by 2, that means 2 into 50 will become 100 here, minus it will become 2Q. This is our inverse demand function. So I can write P is equal to 100 minus 2Q. Okay, now what is the profit maximizing condition in case of monopoly? So profit maximizing condition in case of monopoly is, profit maximization in case of monopoly requires that we equate the marginal revenue of the firm with its marginal cost. Okay, so we need to find out the marginal revenue and marginal cost. To find out the marginal revenue, first we should know what is the total revenue. Okay, so first thing is we find out the total revenue. What is total revenue? Simply price into output. So P is this very function, that is 100 minus 2Q. To this we multiply by Q. This will give us the total revenue. So total revenue will be equal to 100Q minus 2 into 2 is, Q into Q is Q square. We get 2Q square. This is our total revenue function. Next thing is we find out what we call the marginal revenue. And what will be the marginal revenue? Marginal revenue is simply the change in the total revenue due to change in the output. That is the derivative of the total revenue function with respect to output. Now the derivative of Q is 1, so we are left with 100 here, minus derivative of Q square is 2Q, so 2 into 2 is 4, and exponent is subtracted by 1, so 2 minus 1 is 1. So this is our marginal revenue function. Similarly, we need to find out the marginal cost function. So what is marginal cost? Marginal cost is simply the change in the cost function, the change in the total cost due to the change in the output. Okay, and it is simply the derivative of the cost function with respect to Q. Derivative of a constant is 0, so 50, its derivative is 0. Derivative of Q in the second term is 1, so we are left with 40. Okay, implies our marginal cost is equal to 40. Let us also draw the graph here to make it sense. So we have output on the horizontal axis, price on the vertical axis. We have this inverse demand function. It is price intercept is 100 and it is downward sloping. Here you can see. Let us draw it like this. This is our average revenue function or inverse demand function, and its price intercept is 100. What we call the average revenue also. This is our average revenue function. Then we have the marginal revenue function. Here you can see the slope, the intercept is same, but slope is twice that of the inverse demand function. So for marginal revenue function, we have again same intercept, but its slope is twice the average revenue function. So this is our marginal revenue function. Okay, what about marginal cost? Marginal cost is 40 constant, and if we draw it here, so let's draw it here like this. This is our marginal cost function. Okay, now profit is maximized when marginal revenue equates the marginal cost, as we have shown it here. So profit maximization requires marginal revenue should be equal to the marginal cost. Marginal revenue is sorry, 100 minus 4q, and we equate it with the marginal cost, which is 40. Solving for q, and here we will get, transposing this here, it will become plus 4q is equal to 100 minus 40 is 60, dividing both sides by 4, we will get q is equal to 15. So profit maximizing level of output will be equal to 15. So this is the point where marginal revenue and marginal costs intersect each other. So when output produced is 15, okay, so this is our marginal, sorry, the profit maximizing level of output. Now what about the price? We simply plug this profit maximizing level of output into the inverse demand function to find out the profit maximizing level of price. So P will be equal to, so this is our inverse demand function. So we have 100 minus 2 times Q is 15. So this becomes 100 minus 30, which is 70. So profit maximizing level of what we call price will be equal to 70. Now next is question was find out the total revenue. So what will be the total revenue? As we know, total revenue is simply equal to price into output. So P is equal to 70 and output is 15. So this becomes, so we have 0, 7 5s are 35, 7 1s are 7, 8 9 10, 1050 is our total revenue. Now what about the total cost? So total cost is being given us, the function is 50 plus 40 Q. So we have 50 plus 40, the value of Q is 15, profit maximizing level of output. So we have 50 plus, we have 0 here, 4 5s are 20, 4 1s are 4 5 6, so it is 650 is the total cost. And let us first, so here it is the profit maximizing level of price, that is P is equal to 70. Now last part is to find out the profit. Profit we know it is equal to total revenue minus total cost. Total revenue we calculated it as 1050. To this we subtracted the total cost, which is 650. So it becomes 0 0 5 0 so profit maximum profit will be equal to 400. I hope I make myself clear in this video. Thank you.